The next founder on stage is Philipp from Brainamics, and they've developed a software for brain-computer interfaces, and he told me that they're able to extract emotions from the human brain, and he will tell us more about what this actually means. So welcome, Philipp from TU Munich.
Brain-computer interfaces will change our lives more than any other technology ever did before. The technology to measure brain activity has been there for years already. Yet, there are no brain-centered applications bringing any value to our daily lives. We could already be controlling our smartphones, not with our fingers, but with our brains. Why can we not do that yet? It's because it's crazy difficult to process brain activity in real time and integrate it in apps. You would need to be an expert in neurotech, deep learning, psychology, and software engineering, which is not the standard expertise that you can find in an app development company. Now, our mission at Brainamics is to make brain-centered app development as easy as making any other app. We therefore take care of all the complex brain data processing so that the developers can focus on what they're really good at. We package our expertise into a tool, the Brainamics SDK, that for the first time enables app developers to easily create brain-centered applications. So what gives us the credibility to take care of this super complex task? It's the fact that we already built a successful brain-centered application ourselves. Using brain-computer interfaces, we are measuring the brain activity of players while they play a video game. And then we apply our deep learning models to show exactly what they feel, which emotions do they perceive during every single second of the game. With this novel approach to testing games, we're currently completely revolutionizing the way developers test, validate, and optimize the user experience in their games. To make that happen, we already raised $500,000 earlier this year and are now raising another $2 million, for which we already found a lead investor. Good news, though, is that it's still not too late for co-investors, which is why now is exactly the right time to join us in making brain-computer interfaces accessible for everyone. Thank you.
Okay, there are already lots of questions.
Yeah, thanks for the really concrete call of action in the end. I like that. What's your average classification accuracy?
Yeah.
Accuracy.
Yes, so we classify emotions on 2 dimensions. So one is called valence, one is called arousal. It's basically giving you a measure for how active and how positive the emotion was. And there we have an 80% accuracy at the moment.
80%?
Yeah.
I think this is also the market average, right?
I mean, there's no real market average since we are the only one who provides something like this with EEG data. There are some research papers which are on a very limited and closed environment where they have like 10 participants and they also can sometimes achieve up to 80%. But we are able to apply this on scale. So we don't have a problem with inter-subject variability. We can apply that on any human basically, and most importantly on any hardware device. So we are not locked into one specific EEG. We can apply our technology and our software on literally any EEG in the world.
And which data sets are you using? Do you create them on your own?
Yeah, so we created a small data set on our own, and then we use self-supervised learning to utilize all the unlabeled EEG data that is available worldwide. So there's a lot of high-quality EEG data available from medical use cases, but they're not usable for normal machine learning or deep learning. And that's why we created a self-supervised approach, which is also our secret sauce to a certain extent, because now we have the most accurate models.
How many people in the audience have an EEG headset? Raise your hand. How are you going to solve that problem?
Yeah, so we see the problem not that the hardware is hard to implement. So hardware is the easy part. We just need to bring it to the people. People don't have it because there are no use cases for them. Why would you buy an EEG? Because there's no value that you would get in that. And that's what we try to help with. We want to enable app developers to develop great apps that will then, on the other hand, motivate people to buy EEGs. Because Apple, for example, they already published patents on AR glasses that they want to develop with embedded electrodes to measure the brain activity. There are VR headsets with embedded electrodes. The technology is there. It's just about the use cases that needs to be developed. And there our software is pretty nice to use.
You mentioned your first use case being in the gaming industry to sort of improve game development. It's a very clear and nice one. Have you got any feedback from your customers who've already paid like 80K and stuff? How it compares to how they're currently testing and what the improvement has been noticed so far?
Yeah, so the difference is the depth and insights that they can get. So typically they do surveys and sometimes they verbally interview the testers after the play test. And what they get with us is a way better temporal resolution. So they see for every single second what do they feel, and they get an objective insight. So they're not relying on the subjectivity of the participants, because humans in general are really bad in expressing, like verbally expressing what they felt. And that's where our approach comes in quite handy.
And right now you are having actual revenue from game developers, and the end game will be maybe in AR glasses or whatever I will wear at that time. What do you do? How do you bridge the time in between there? I mean, I assume you could do all sorts of market research with this or other stuff.
Exactly. So just the gaming itself is already a multi-billion-dollar market. Our technology could be one-on-one applied also in test screenings in movie production, for advertisement testing. Wherever you have a digital user experience where you want to test what the users actually feel, you could apply our technology. And that's kind of what we want to do until hardware becomes available on the mass market.
What's your larger vision for your company, but for the entire industry? I mean, where will it take us if we are able to extract brain thoughts?
The ultimate vision is that we can control our devices, such as a smartphone, just by thinking. That we can have the most easiest connection between our brain and machines that we are using, to remove all the barriers that are existing there.
And what do you think, how many years will take that until we get there?
5 to 10, so still a long way down the road.
How device agnostic is your software layer?
How device agnostic is our software layer? Totally device agnostic. So we can apply our technology, our software on any EEG that is on the market. So we buy EEGs off the shelf and we can apply it to anyone.
But it's dependent on being an EEG cap. Like you can't use ear-based electrodes or FNIRs or anything else.
Exactly. So we cannot use FNIRs or MEG or any other one. But the good thing is EEGs is the cheapest and the most scalable one. That's why that's not a problem.
Thank you so much, Philipp. Thank you.
Thank you.